Okay, so good morning and let's get started. So, sorry. So we're going to talk today like how do you convert a regular expression to a finite automata or vice versa, right? So this is to be noted that all the regular expressions are actually nothing but they represent regular language. So therefore, each of these whatever you can write as a regular expression can also be converted to finite automata, right? So deterministic finite automation. Um, so how will we do that, right? So let's first understand. So any regular expression is nothing but so we have seen the definition of regular expression. Regular expression is either a symbol, right? So R is either A. So when you say R equal to A, so A, we're talking about A is a sigma, A is an alphabet. R, so regular expression is either a single alphabet. If it is a single alphabet, that means the language accepted by this is equivalent to saying that the language accepted or the corresponding language is a single variable A, right? These two are equivalent. This R is a regular expression, but this LR is the language. Right? So now, if you have to convert a regular expression to finite automata, we should know how to convert each of these things. Right? So, for example, how do you get a regular expression for a language LR? Sorry, how do you get a finite automata for LR? So, finite automata for LR will look very simple. It will be starting here, and by reading A, it will go to the final state, right? So this is we can call it NFA. Just let's do NFA because we know how to convert NFA to DFA, but this is a perfectly fine NFA, right? So this so now we know how to convert R equal to A as a NFA. Similarly, if R can be A or R can be epsilon, right? Empty string. So this also means that L of R, right? So this three lines here that denotes that is equivalent, right? So this is for equivalent. L of R is empty string, right? L of R is empty string. And how do you draw a finite automata for this? Anyone? How do you draw finite automation for this? How many states it will have? Finite automation for LR. How many states it will have? One. Yes. So without doing anything, the first state itself will be the final state, right? So this is allowance. Third, how do you draw a finite automation for R if R is 5? If R is 5, that also implies that N of R is 5, nothing, right? So this means the language accepts nothing. And if the language accepts nothing, that means that only one state and there is no final state. So the final state is empty. So we can draw like this. And if you remember the definition of sorry, definition of mm, regular expression, it is either of these three or it is union of right? So it is union of R1 union R2, where R1 and R2 are regular expression, or it is R1 concate R2, right? And this is nothing but R1 star. So if we know how to draw finite automation corresponding to all these, we are done, right? So if because we know how to draw finite automation for the first three cases. Right? First three cases means R is either A, or R is epsilon, or R is pi. We know how to draw finite automation for this. Now, only thing we need to do is we also need to know how to draw finite automations for these three guys, 4, 5, and 6. So how do you do that? So let's look into this. Very simply first, let's try to draw a very simple automations like A union B. Right? If we can draw a automation for A union B, how do you draw? So whenever there is union, right? Union means it is either A or B. So anything, wherever there is union, you will have two parts, right? Because that's the end operation. So any one union operation. So either of these is will give you final state. When I say A union B, this is the finite automation corresponding to that. And why this finite automation is correct? Because you have A and union B, right? So either of these is with either of these you will reach final state. So A union B. Similarly, you can also draw. So we have seen so how do you draw for concave? So let's say concave is like R is AB. It's again very simple. I will draw A and B. Done. Right? This is perfectly fine. NFA where R is equal to AB. How do you draw for A star? Is let's say A star. A star means it can be one or sorry, it can have zero or more A's. So how many states it will have? R equal to A star. If I draw NFA for this, how many states it should have? Anyone? Two single. Yeah, so some are saying two, but you can actually draw with single state, no? Because see, how do you draw? The same state will be final state, and then A, right? So this guy, the finite automation, what we have drawn is can recognize empty, right? Because without reading anything, it's reaching the final state. It can read A, it can read AA, it can read A, and so on. So this is actually reading A star, right? All right. What about so this? So now we have seen that we know how to draw for each of these primitives, right? So the primitives are the first three, which said R is A, R is epsilon, R is pi, and all these 4, 5, 6. So that means we can draw regular. That means we know how to draw finite automation for any regular expression, any given regular expression. You can actually draw, and you can try doing that. But let's first do one few more things before we move. So let's say your R is A plus. What is the A plus? A plus means it should have at least one A, or it can have more than one A. So it is one or more A's. How many states it will have? If I try to draw two states, correct? Because it will have two states because it should read A and then it should keep reading A's here, right? This is R equal to A plus. Now let's try to draw finite automation for slightly complicated case. So there are some rules, like slightly different rules, but we will first see simple techniques, and with whatever we know, we can try to do that, and then we will move to something more complicated. So let's say I need to draw a finite automation for a very simple regular expression. This is draw FA. So FA means you can say that, let's call it NFA for regular expression 1, 0 plus 1 star. Uh, okay, before that, I think let's do one thing first before jumping to this problem. Let's do one thing more. So let me ask you a question. Let's say your R is A union B star. How will you do this, right? So we have seen how to draw for A union B. We have seen how to draw for A star, right? So those are what we have seen. Now, how do you do A union B star? A union B star. So A union B star, how many states it should have? Anyone? A union B star. Yeah, right. So A union B star is going to accept empty string. So that means the first state, it should be the final state as well. And then it should do anything, right? So it's A comma B. If I do like this is this is perfectly fine. Only one state is perfectly fine, and this will recognize anything. So what does this mean? This means either epsilon or A or A, anything like so A, and so on, right? So this guy is doing A union B star. Okay, so this is how you draw for A union B star. So whenever there is A union B star, you can simply draw. So now we have seen some of the primitives, like these are I'm calling them primitive because all the bigger expressions you will see in this world will be some combination of these things, right? So it will not be very different. So at least we know the atomic things or primitive things. Now let's see how do you combine it and make a finite automation for something bigger. So let's say I have a regular expression which is given to us. I have to draw finite automation for this. So 1, 0 union 1 star 0. Okay, and draw an FA for this. Draw FA for this. Okay, what does it mean? So we have three parts. If you see, like if you look into this particular example, we have three parts. This is part 1, this is part 2, and this is part 3. And these are concatenation, right? So you have concate between these things. So we know how to do concate. So let's try to do that first. So we know how to do concate. One. Oh, just a minute. So let's call it not do like this. Then this part will be 0 union 1 star. Let's say we don't care about how to do that first. And 0 right? This the whatever in the rectangle is not drawn yet, but that should consider a finite automation for 0, 1 star, right? And the final state is the last one, and this is we are doing just for the concatenation. Now concate, but now also we have just seen that we know also this 0, 1 star. Hmm. So that's all. So this finite automation is equivalent to your the one which is given, right? So this finite automation is equivalent to the regular expression which is given, and it will do exactly the same job. Okay. Now let's look into some more example. The question is, can you explain how 0 union 1 contains all string of 0 and 1? 0 union 1 alone does not contain all the string. So 0 union 1 star, right? 0 union 1 star contains all possible binary string. Why is that? Because when we say 0 union 1 star, what does it mean? It means that 0 or more 0 union 1, right? So you can choose 0 union 1 either 0 times or multiple times. So every time you have a flexibility. Let's say you choose 0 first time, second time you choose 1, then 0, and then 0, 0, 0, 1, 0, whatever you want, you can choose it multiple times. Star is, yeah, star means you can actually have to repeat, right? So this 0 union means you can read it 0 or 1, 0 or 1 multiple times. That's the meaning, right? So in English, you can say like 0 or 1, 0 or multiple times. So if you do that, it will be coming all the binary string, right? So any binary string you can choose, and you can actually generate that binary string using this particular regular expression. Okay. Good. So let's take see more example. Yeah, slightly complicated ones. So we have A, B union A star. A, B union A star. This is your regular expression. How do you convert it? Okay. You know how to do this union A star, right? So the thing which we know, let's try to do that first. We know how to do, right? This will do, but this is not perfectly fine, right? Because the issue is, so this is just saying that A, B, A, right? We don't want this. So what we want is something like this. So we can see now this has this, you can draw like this, but this is not complete, right? So the one thing which we want to make it slightly differently for this particular thing is let's try to approach it in a different way. So the thing is, you all agree that for this particular regular expression, the first start state will be final state, right? This is not enough. So this everyone will agree that the start state will be final state, because there is A, B union A star means it should accept empty. So therefore, this is perfectly fine. Now, how do we know? We know how to draw for this AB, right? How to draw for AB? A. We know how to draw for AB. We also know how to draw for A. right? Now, what is that we are going to do is repeating, right? So here repetition will be, now you need to see like AB star. That means you should also read A and go to some state and then B. Is this fine for AB star? Is this particular part, like let me draw it in a separate color. This part. Is this part doing AB plus AB star? This part is doing AB star, right? AB star. Because you can have either 0 AB, 1 AB, 2 AB, 3 AB, 4 AB, and so on. Right? So this is doing AB. How to do A star? Because we have to do AB star as well as A star, right? So AB star and as well as A star. So A star is, you can do it. Why? Again, adding one more A here. Right? So this part will do the, let's call it a green part. Green part will do A star. And the combined thing, because there is a branch, right? So it will either go to the green branch or it will go to the yellow branch. So repeating these things is actually same thing as AB union A star, right? AB union A star. Whatever you can generate with AB union A star, you can generate with this. Any question on this? It does not accept ABA. Hmm. Yeah, that's correct. ABA. Yeah, so therefore you need some epsilon transition here. That's correct. So how do you do that? ABA. This is doing AB A star and it is doing A star, but so it's actually doing this thing like that. So it's actually doing AB star union A star. AB union star A star. Question is this equal to AB union A? Not, right? This is not equal. So there is something more needs to be done here. So the better way, yeah, so that's good point. So this is not completely correct. This is for correct for this one, but not for this.
Uh, Then the last page we can make these A accepted that go from null to towards AB, right?
Can you say that again?
The branches that are going from the start state to AB accept state. In between, we have a state corresponding to A.
Hmm.
We can make them accept states.
Yeah, so you can do that. So what you can do is because A is anyway going here, right? So you can also come with like this and make it A, right? Will that do? That will do. So what he is saying, let's say, let's draw it again. Okay, so what sounds is trying to say perhaps is you have A and you also have A here. You have B here. Oh, sorry. A here, B here, and this is your final state anyway. This is also our final state. Will it work? A B union A star. Of course, this will be final. Now, whenever you choose either A B, you can do multiple of them. So AB is star is fine, and then ABA. If you say ABA, this is still not correct, right? So AB.
So for ABA, the state which is left should also be the except state.
So everything is final then. If it is ABA, it is final. Then what is that? It is not doing. So will it do ABB? It will not. Right. So that is fine. This would not do also. But AA is fine. AAB is fine, is it? AAB. A. No. Yeah, I think this is not the right way. Let's look into try to do it with epsilon transition. So yes, this way we will be lost. Okay, so let's try to do very primitively. So what is the problem we have is AB union A star, right? So what we know is how to draw for A. Right? We know how to draw for A. We also know how to draw for B. Yes, yeah. You know how to draw for B. You also know how to draw for AB, right? So A, AB, final state, right? So how do you draw it for AB union A? Now let's look into that. AB union A. This you have to draw. So how do you draw this? You can do this by different ways. One is with the null transition. So null transition is combining these two, right? So how do you combine? You remember the union logic. You know how to draw for AB. Sorry. This part. AB. And then this part is A. Right? So because this is the similar logic with AB thing. Now this is AB union A. All right. Now how do you draw it for AB union A star? Right? How do you draw it for AB union A star? So for if you remember the logic for a star is you draw a null transition, right? So you draw a null transition from the final state, right? So this is the final state to the start state, so that it repeats those things, right? So this is the beauty of null transition, perhaps. So what we are doing is we have this null transition, we have this null transition, and we have this A, B, which is the final state, and we have this A, which is also a final state. And since we are doing star, what we will do is we will connect this with null, and we will also connect this with null, and we will also make this final state. Why we will make final state? Because empty also should be allowed, right? So with that you can actually do simply even the empty will be allowed. So this should do all the things what we are talking. This will do AB union A star. Any question? I don't know. We can have initial state with self loop of A, and then move the from initial state to second state accepting A, and then from second state to accepting B. So what's Surabhi is suggesting A, if I'm drawing it right, A, B. Is that the thing?
No, sir.
No?
Sir, I was telling that the initial state will be final state
Is
because it
it?
can accept null also.
Okay. I
And then
didn't.
from where the second state is there, from second state again to initial state, and that will be the B.
This, yes,
Yes,
is.
and you can
Okay.
remove that B part from there.
Okay. Is this correct? So it will definitely do null, right? It will do anytime A, and AB it will also do, and multiple ABs it will do, and yeah, looks like correct, right? Anything else? Yes, good. Yeah, so but the thing is, it's better you go by the simple rules which you know, because the thing is, it might be very complicated when you have a large regular expression. So it's better to break them as we did in this example with epsilon transition. So we know primitives, try to combine that using, let's say, if it is union, and you also know how to combine these things with for the star. And once you have an NFA, you know how to convert DFA, but that's how maybe better way to proceed. But yeah, sometimes if something comes up like this, it's great, right? So you can also do that way. Another question, I'm not solving it, but it's for your exercise. So let's, this is for your exercise. Uh, A union B star ABA. All right. If you read it in English, what does it mean? If you read it in English, what does this regular English regular expression means? String that ends with ABA, right? Any string that ends with ABA. So you can either adopt that idea of how to draw a finite automation for a string ending with ABA because you know that, or you can also break this into primitives and try to solve them individually, right? So you can break them into this ABA, how to concate this, and you know how to draw for this part. You also know how to draw for this part, and then combine them. So you can try that. Let's leave in it, but you post it in the classroom maybe. Okay, so now let's look into the other way. What is other way is you have a regular expression given, right? And you want to convert it to, oh sorry, you have a finite automation given, and you want to convert it to regular expression, right? Looks like very similar thing. But so what is given? Finite automation is given, and you have to convert it to regular expression. right? How do you do that? So we'll take a few examples and a few things which you can directly do. I don't have to go by the steps, but few complex things we will see the steps. So let me draw a finite automation, and you can actually tell me uh, what is the regular expression corresponding to that. So let's do this exercise, and then you can see some better method. A, B, this, right? So this is finite automation, and let's call it B. Right? What is the regular expression corresponding to this? What is the regular expression corresponding to this? Anyone? So whenever there is AB star, no, I have drawn something more. Yeah, this is B star AB star, right? So B star AB star. Why is that? Because so there is something. Yeah, I have not drawn for A, but let's see, let it be like that. But so this is B star AB star, because B can be many times. Then you have A, and then you can have many times B. All right. What happens if you have something like this? A comma B, A comma B. What is this? So this is A plus B, A union B star. Yeah. Whenever there is comma, right? So A, B, there is comma means either of these, right? So either A or B you choose, you can go to the final state. And then either A or B you choose, you can go to the final state. So it is A union B plus. Any question? Good. Let's take one more simple example. Let's say I have A, A, let's call it AB. Okay, slightly complicated, no? So what is happening here? And this is, sorry, this is not complete. This is AB. Yeah. So first thing is it is accepting empty string, right? So it should accept empty string. It's doing that. And then it is also doing A union B. So it is doing A union B, right? Then you have A star, then you have B, then you have A union B star. A union B, and then A star, and then B, and then A union B star, and also null. Any question? Right, so this is null union, null empty union, because empty is required because the first is also made final. So empty union, this particular things. Good. How much time we have? Okay, we have some time at least. Let's take one more example, but this example we will not do by this simple intuition based things, but slightly more procedural. So this example is again slightly complicated. We will use something called Arden's law. We will see what is that. So I have a Q1, A, Q2, B, A, Q4, AB, Q3, A, B. Okay. So now this is the finite automation given, and you have to come up with a regular expression corresponding to this. Right? We'll go, you may try it also, like if you think a little bit, you can, it's not very hard, but we will go slightly procedural so that you know, understand the procedure. So the procedure what we are going to follow is, we'll write these states as follows. We write Q1. Okay, so each of the state we will represent Q1 by the incoming, sorry, they start a state. So incoming transitions. For example, Q1 there is incoming what are the incoming transitions for Q1? This is one incoming transition, this is one incoming transition, and this itself is one incoming transition. So since it is a start state, it has an incoming transition from nowhere, so it should be null. And then it has an incoming transition from 2, so Q2. So this is Q2A. And similarly, it has an incoming transition from Q3, so it is Q3A. Right? Simply, we can write Q2. Very similar way. So Q2 has only one incoming transition. Right? So Q2 has only one incoming transition, which is from Q1. So we can write it Q1A. Q3 has only one incoming transition from Q1, that is Q1B. Only this incoming transition. Now you have Q4. Q4 has 1, 2, 3, 4 incoming transitions. One is from Q2, Q2A. One is from Q3, Q3B. One is from Q4 itself, Q4A, and another is from Q4 itself, Q4B. Equation 1, equation 2, equation 3, equation 4. Right, so these are the 4 equations, and now we will try to represent the final state. Right, so how do you represent the final state? We need to represent it with all others. Right, so let's say Q1. Q1 is null plus Q2A plus Q3A. All right, and this I can represent. So this one is null plus Q1. Q2 is nothing but Q1, right? So Q1A, Q1A. So this is AA plus Q1B right? So this is Q1B, and what is this is Q1. So Q1, just a minute. So I can write it null plus Q1 E. Just a minute, there is something going wrong. Q2, Q2B, Q2 equal to Q1A. Q3 is Q1B. Oh, there is some minor mistake here. It should be B, no? Q2B, because it is coming from B, right? So this B. So Q2B, and this is B. And similarly, we have Q2A, Q1AB, AB plus BA, AB plus BA. Okay, Q1 equal to Q1 null plus Q1 plus BA. Okay, so that's what we have got. So this is what we got. Q1 is equal to null plus epsilon plus Q1 AB plus BA. There is a formula called Arden's theorem. So we have not discussed it, but now we can use it. So Arden's theorem says that if you can represent the things as R equal to Q plus RP, then R can be written as QP star. Okay, this is just this is called Arden's theorem. You need to remember. So now here R equal to Q plus RP, and you can actually also derive. It's not very difficult, but R equal to Q plus RP. So what is R here? R is, in this case, this is our R, this is our Q, and this is our R again, and this is P. Okay? This AB plus BA is P. So then R can be written as QP star. So that means Q1 can be written as QP star. Right? And null can be actually omitted because null does not make any sense. So this is QP plus BA star. Long formula, but long procedure, but it will be helpful if you do it for complex questions. So this is AB plus BA star. So either it is AB plus BA star, and some of you might have already answered it without using this complex procedure. But still, the importance of this complex procedure is like if these things are quite complex, like it's not anything is not coming, then you can try in this way, and you can try representing the final state using you can try represent the final state using all other states and all other things. And if you come up with something like this, no, Q equal to RP plus R equal to Q plus RP, and then you know what is R. Okay. But yeah, this is all like requires some amount of practice to come up with some answer. We will stop here today. 9:53 already. Maybe I think it requires maybe one more lecture on this particular topic, because I think this is something which requires more practice. And then we will move to non-regular language and pumping lemma. So next week, we are slightly lagging. Maybe we need to do a couple of Q1 is R. Is Q1. Yeah. In this example, yes. R equal to Q plus RP. Q1 is R. Yeah. So in the maybe we need to do one or two extra lectures sometime. We'll see when to do because it's maybe not lagging significantly, but maybe lagging for 1-2 lecture. Because next week I was planning to do this context-free grammar and all, but that's okay. And then Turing machine. So we have 3 weeks time left now, if I'm not wrong. Just let me check. So 1, 2, 3, yeah. So 1 week will go in Turing machine, 1 week in compilers, and 1 week, yeah, okay. And we also need to complete actually 5 quizzes. So this in this 3 week. So we'll have some quiz next week for sure. And this next week quiz will be more on regular expressions and pumping lemma. Sometime we will do that maybe towards Thursday or Friday. Okay. Anything else? So today is just 26 people attending. Okay. All right. So thanks. See you next week.